look at example 2. It asks if angle EGD would be from E through G to D. So this angle here, is that congruent to EFH, which is this angle here? Okay, they want to know if that's true. Okay, and based on what I can see, once again we have what's called overlapping triangles. We got this triangle has a part that matches that triangle, has a part that matches that triangle. I'm not sure exactly the path they want to take on this, but if it were me looking at it, I would start with this big triangle here. Triangle EBH. Because that's got some stuff marked in it, right? Specifically, I know that this side is marked congruent to this side, which means which two angles have to be congruent?
Angle D and angle H.
Angle D and H, right? Because we go across the triangle, go across the triangle. This angle here has to equal this angle here. They have to be congruent to one another. All right? Let me erase my things there. So, looking then at these two triangles, these smaller triangles, let me just get a different color here. Let's go with green. If you look at this triangle here, which is EDF, and EHG, I'm going to record down stuff that we know as we find out. So I know that angle D is congruent to angle H. We already know that ED and EH are congruent. Right? That's congruent to that. These are congruent because of the isosceles triangle theorem, right? So angles opposite equal sides are equal, or angles opposite congruent sides are congruent. Look at these little green triangles I got identified here, EDF and EHG. Notice that DF is congruent to GH. Right, so this was given, this was the isosceles triangle theorem, right? Which two triangles are congruent?
EHG and EDF.
EHG and EDF, right? These two triangles here are side angle, side congruence. We got going on there, right? So I know the triangle, let's call it EDF on this one, is congruent to triangle something. We got to make sure we name it correctly. So I know that D and H corresponds to D in the middle, H in the middle. I need the first and last letter. Since this angle down here, or this side down here matches that side down there, this angle up here should match this angle up here. So that's angle E for both, so E in front. And that implies then that F and G would have to be the same, so G goes last. Again, that's my side angle side. Right? I'm still trying to show that F and G are congruent to one another. How did I show D and H were congruent?
The two sides.
These two sides were congruent, so the angles opposite were congruent, right? Notice the angles we're looking for, which is this angle and this angle, are opposite this side and this side. So if I get those sides to be congruent, it's the same idea for those two angles we're looking for, EGD and EFH. So, is EF congruent to EG? The question is this congruent to this? Question mark. Have we shown enough to show they're congruent? What's this statement say?
Triangle EDF equals EHG.
Right, EDF and EHG are congruent? Are EF and EG part of those
Yes.
triangles? Yes, are they
Yeah.
corresponding parts?
Mm-hmm.
Sure they are. So corresponding parts of congruent triangles are congruent, so I know that EF must be congruent to EG. And once I know EF is congruent to EG, then I know the two angles down here, specifically this angle and this angle. I should have to use 2 marks instead of 3 here. These are going to be congruent for the same reason D and H were congruent, right? These sides are congruent. Isosceles triangle theorem says that angle EFG is congruent to angle EFH. Congruent to EGB. I just tried to use the same letters they used. Did it backwards, but it means the same thing. Again, it's not a formal proof, but if you just take a look at what's going on here, this is given here. This is isosceles triangle theorem. This is side angle side. This is CPCTC. And this is isosceles triangle theorem. If I'm writing a formal proof, I'm going to put those two things up there first, right? So a lot of times they're going to say, is this true, or show that this is, that kind of thing. You're basically walking through the idea of a proof without writing a formal proof out of it. Use sequential logic. One thing leads to another thing, leads to another thing, until you get to what you're trying to show. And by all means, draw the picture well. Use a straight edge. Try and get it looking right. Label it well. Don't write it so tiny you can't mark on it. Seeing students try to draw this picture and they'll do this on their paper. Let's draw that as actual size, instead of like actually taking up some space from the paper. Make sure you make it big enough that you can actually doctor it up a little bit, make marks on it, and be able to see what you're writing. The smaller you write, the harder it is to see what you're doing, so use some space.